Hello everyone. In this video we are going to talk about breadth first search, which is the abbreviation of DFS algorithm. It falls under the category of graph traversals. Let's first explore what graph traversal means. Graph traversal means visiting every vertex and edge exactly once in a well-defined order. So while using certain graph algorithms, you must ensure that each vertex of the graph is visited exactly once. Order and tracking are important aspects of graph traversals. So what that means is that the order in which the vertices are visited are important and may depend upon the algorithm or question that you are solving. And during a traversal, it is important that you track which vertices have been visited. The most common way of tracking vertices is to mark them. Now, depth first search is a backtracking algorithm. So what it means is that it is a recursive algorithm that uses the idea of backtracking, and it involves exhaustive search of all the nodes by going ahead if possible, else by this backtracking. Now what backtrack means is that when you are moving forward and there are no more nodes along the current path, you move backwards on the same path to find the nodes to traverse. Now all the nodes will be visited on the current path till all the unvisited nodes have been traversed, after which the next path will be selected. Now this recursive nature of DFS can be implemented using stacks, obviously. The basic idea is as follows. So this is the basic algorithm that will be followed, that is followed in depth first search. Picking a starting node and push all its adjacent nodes into a stack. Pop a node from the stack to select the next node to visit and push all its adjacent nodes onto the stack. And repeat this process until the stack is empty. However, ensure that all nodes are visited and they are marked. This will prevent you from visiting the same node more than once. If you do not mark the nodes that are visited and you visit the same node more than once, you may end up in an infinite loop. Now here's the pseudocode for DFS algorithm. So you have two inputs: the graph that we wish to perform this DFS algorithm on, and the starting vertex. And what it gives is a collection of vertices reachable from this V, the starting point, with their discovery edges. How do we implement that? We label the starting node as discovered or marked, and for all the edges that are adjacent to this starting node, what we do is, if this vertex that is adjacent to this node, input node, is not labeled as discovered or not marked, then we will recursively call DFS on that adjacent node. This is how it works. So in short, it is a recursive algorithm. Now what are the requirements? It can be used to attempt to visit all the nodes of a graph in a systematic manner. It works with directed and undirected graphs, and also with weighted and unweighted graphs. Let's look at a basic scenario. Imagine that you get stuck in a maze like this. There might be multiple routes from your starting position, let's say this is your starting position, to the exit. Okay, the natural approach to getting out of the maze is to try all the paths that are available. You keep making moves and you keep moving forward, and then you hit a dead end. Now you would ideally want to try a different path, obviously, and so you backtrack to previous checkpoint like this, where you made one of the choices, and then you try a new one. Okay, that is a different path this time. You keep doing this until you find the exit. That means that recursively trying out specific paths and backtracking are the two components forming the depth first search algorithm, the DFS algorithm. So these are the basis for this algorithm. Let's look at an example. So you have this graph before you, For this you need two data structures. One is an array in which you will hold all the nodes and you keep the check marks whether it is visited or not, and another data structure which is stack, in which you will hold the node that we are currently visiting. So what we want to do is we want to conduct a depth first search of the graph starting with the node D. Okay, so we will start here. So the algorithm states that starting with this one, what we do is firstly we mark this node. Okay, whichever node we visit, we mark it and put it into the stack or push it into the stack. That means we are visiting that node. Now there are three paths, C, F and E, that are directly connected to D, or in short from where we can go from D. So we visit that node. We can visit any node in any order, but let's say we visit them in alphabetical order. So because C comes first, so we decide to visit C next. So whenever we visit an unmarked node, what we do is we mark it as visited and we also push it into the stack. We will do the same for C as well. So we mark it as visited and we push it into the stack. So because we are visiting C, so we'll see what are the adjacent nodes that can be visited from C. As you can see, there are no paths leading from C. So what we do is we pop it out of the stack, and because it is already visited, so we don't need to visit it again. So there are no no nodes adjacent to C, so we cannot continue, that is we cannot backtrack, and we pop it out and we backtrack. Now D to C has been visited. Next comes E, so we visit E next. We mark it and push it into the stack. From E we can go only one way, which is G, so we decide to visit G next. Okay, so we mark it and push it into the stack. From G we can go two ways, H and D. Because we are following alphabetical order, so we will start with D. D has already been visited, or it has been marked, so we will not visit D. So H is the only option here, so we will visit H next. When we visit H, we mark it and we push it into the stack. From H we can go two ways, either A or B. Because we are following alphabetical order, we decide to visit A next. When we visit A, we mark it and push it into the stack. From A we have only one path leading towards B, so we mark it and push it to the stack. From B we cannot go anywhere, so what we do is we pop it out of the stack and backtrack. The previous node was A, as can be seen from the top of the stack, so we pop it out because there is no path leading from A other than B. Next is H, and we have already visited all the nodes that are connected to H directly, so we pop it out as well. Next in line is G, and we have already visited all the nodes that are directly connected to G, so we pop it out as well. Next is E, we have visited all the nodes adjacent to E, so we pop it out. And via backtracking we are back towards D, and from D there is only one unvisited node, that is F, so we visit F and push it into the stack. And from F we can only go one way, which is C, which is already visited, so what we do is we pop it out of the stack and we are back to D. Now no adjacent nodes are left that are not visited from D, so we pop it out. And this is where your depthward traversal is done. These are the orders in which we have visited the nodes. First we started with D, then C, then E, then G, then H, then A, then B, and lastly we visited F. This is how depth first search algorithm works.